So with this question, we've got a diver. Sorry, bad drawing. His center of mass is 1 meter above the board, and the board is 10 meters above the surface of the water. And he'll dive like this, and his maximum height here is 1.11 meters above his center of mass, and the angle that he launches at here is 80.2 degrees above the horizontal. So in the first part, we want to calculate the time to maximum height. So there's a few different ways that we can do this. I'm going to consider the equation v squared equals u squared plus 2as in the vertical direction. So put my little y subscripts here. So this, with what I've been given, will allow me to calculate the initial y speed, which will also be useful for part 2. So that's why I think it's a good way to approach part 1. Okay, so at the maximum height, we've got Vy is equal to 0. So this is 0, and we can get the initial speed. So vertically, Ay is equal to minus 9.80, and we've got that the height above the initial point is equal to 1.1 meters. Okay, so we've got uy squared is equal to minus 2ay sy, so this is equal to minus 2 times minus 9.80 times 1.11. Solving this, we get 21.756, and so uy is equal to 4.664 meters per second. So now we've got the initial vertical component of the speed. And what we're asked for is the time to maximum height. We know at maximum height the speed is 0. So now we can use another kinematic equation. We can use v is equal to u plus a t in the y direction again to work out t. So rearranging this, we've got t is equal to vy minus uy over ay, and so this is equal to 0 minus 4.664 over minus 9.80, the negative because it's downwards, and so solving this for time, I get 0.476 seconds. Okay, now part 2 asks us what's the magnitude of the initial velocity of the diver. Okay, so the diver's going up like this. This is 80.2 degrees, and we've just calculated here the initial vertical speed. So this is 4.664. We don't know the horizontal speed, but because we do know the angle, we can say, well, this is the initial speed here. And so using trigonometry, we've got sine of 80.2 is equal to opposite, which is 4.664 over the hypotenuse, which is u. And so rearranging this, we've got u is equal to 4.664 over sine of 80.2, which we can solve, and we end up with 4.73 meters per second. Now part 3 asks us how far horizontally from the takeoff point does the diver hit the water. Okay, so what we're going to need to know for that is how fast is the diver traveling in the horizontal direction. So we'll want to know this ux here. So let's start by finding that, and then we'll want to know the total time as well. So we can work out ux just with some trigonometry. We can say, well, tan of 80.2 is equal to opposite, which is 4.664 over ux. So rearranging ux is equal to 4.664 over tan of 80.2, and so this is equal to 0.8056 meters per second. Okay, so now I know how fast they're going horizontally, and this doesn't change. what I need to now work out is the total time. So I know the time that it's going to take the diver to get from there to there. I calculated that here. What I now need to work is the time to get from here all the way down to here. So to do that, I'm going to need to consider my vertical components. I can use S is equal to UT plus a half AT squared, and I'm doing vertical, so I'll put my little subscripts Y. Now we're considering the time from here to here. So up here we said that the horizontal speed was 0, so this term is 0, and so I can rearrange this. I've got T squared is equal to 2SY over AY. So this is 2. Now the height, the diver starts from 1.11 meters above his initial center of mass, so the total he falls through that distance, plus the 1 meter of his center of mass above the board, plus the 10 meters back to the water. So that's the total height through which he falls. So it's to there, that's 1.11, to there, that's an additional 1, and that's the additional 10. And then we're dividing this by 9.80. So this is down, so those would both have negatives, but they cancel out. And so we can solve this on the calculator. We take the square root for t, and we get, well, this time is equal to 1.572 seconds. Okay, so T total is going to be equal to the 1.572 plus the 0.476 seconds that it took to get to that maximum height. So this is equal to 2.048 seconds. And so that tells us that the distance is equal to UX times the T total, which we've now calculated both of. So this is 0.8056 times 2.048. Solving this, I end up with 1.65 meters. Okay, so we've now solved this problem.